Now, in this video, our topic is momentum in quantum mechanics. So, in classical mechanics, so momentum that is given by P is m into v, that means mass into velocity, and which also can be written as v can be written as dx by dt. So in case of quantum mechanics, we have to take here expectation value of momentum. So here we will take the expectation value of v. That means in this expression we have to take the expectation value of x here. So we know how to find the expectation value of x. So this is equal to integration minus infinity to plus infinity x and probability density dx, and mod psi square, it is given by psi into psi star. So psi star is the complex conjugate of psi. So now you see, if this is the product of psi and psi star, then what you can do? So if you differentiate with respect to time, then minus plus infinity x partial d by del t of mod psi square dx. So if you apply that here, then if this is the product of psi and psi star, if you apply the product rule, then what you can have, this is integration minus infinity to plus infinity x, and within bracket psi star del psi by del t plus psi del psi star by del t dx. You can have this. Okay, so now if you see the Schrodinger equation for psi, we know the Schrodinger equation. So that is given by I h cut del psi by del t is equal to minus h cut square by twice m second order derivative partial. Okay, then v into psi. Here v represents potential. So this is suppose equation number 1. Now let us multiply its term by minus I by h cut in this equation. Then what you will get? Then you will get partial derivative with respect to time of psi del psi by del t. So here minus so it's going to be plus I h cut by twice m second order derivative, partial derivative here with respect to x, then minus I by h cut v into psi. So you will get this. Okay, so similarly for psi star, as it is complex conjugate of psi, then you will get del psi star by del t. That's gonna be, so make the positive signs negative here, then make the psi star, that's all. This is x, and minus here it will be plus I by h cut v into psi star. So now you see we have got these two. So if you use these two value here, okay, so then what you will get using these two in this above relation here, using the values of del psi by del t and del star psi by del t. So in this relation, then what you will get? Then you will get this, let me write here. So minus infinity to plus infinity integration. So x I h cut by twice m, then within bracket psi star. Here you will get second order derivative of psi, partial derivative. Okay, so then here it will be psi star, then psi. So here it is dx. So here you see, so it can be written as, so I is cut by twice m, this is constant term, so you can write this way. So, and you can separately use the integral part x. So here you see, as we have second order derivative here, partial derivatives, so we can write this integration from minus to plus infinity x. So we can write here del by del x and within bracket psi star. So now we can write del psi by del x minus psi del psi star by del x. So it can be expressed in this way also. So now here you see, now we're going to use the property, use the rule of integration by parts. Here you see, consider this one as f and this term as dz by dx, and if you integrate this integration from a to b, suppose function f and dz by dx, then dx, it gives, what does it give? Now you see, so it will give you, if you apply this rule here, then minus a to b, integration a to b, df by dx z dx plus f z from a to b. Okay, now you see, in this case, so we have assumed this part as dz by dx and this one as f. Okay, so if you integrate this, then according to this rule, then here you will get d by dx of x, that's gonna be 1, isn't it? Then you will get this term, this is z, this part is z, you will get this part psi star del psi by del x minus psi del psi star by del x, you will get this part dx. And here you see this part from minus infinity to plus infinity, psi goes to 0, psi goes to 0, that's why this portion will be 0. Okay, this portion will be 0, so we will obtain this minus this derivative of x is 1, so simply we will get this result. Sorry, minus this, we will get this result after applying integration by parts. Okay, so let's do that. So let us use this value here. So then what we will get? We will get d by dt of expectation value of x and minus I h cut by twice m, then minus infinity to plus infinity, we will get psi star del psi by del x minus psi del psi star by del x dx. So again it can be written as minus I h cut by twice m, and then it can be written as minus infinity to plus infinity psi star del psi by del x dx minus infinity to plus infinity psi del psi star by dx del x dx. So we can write this way. So here you see again in these two, if you apply here in this term again this rule, integration by parts, from integration from a to b, f dg by dx into dx, if you apply this rule here considering psi as f and this one as z dg by dx, then if you apply this rule then you are going to have this result, minus infinity to plus infinity, integration minus infinity to plus infinity d psi by del psi by del x. In this case we have partial derivative, so del psi by del x, then psi star dx plus psi star psi minus infinity to plus infinity. So as psi goes to 0 from minus infinity to plus infinity, this term will be 0. So we have got this term as, because of this minus sign, so this minus will be positive. So hope you have understood this. So here you see this term is same as this one. So here we will get plus minus infinity to plus infinity after application of integration by parts. So you can rearrange this order of these two terms. Here you can see psi star first, then write del psi by del x next dx. So these two are same. So adding these two, this one and this one, so what you will get, so let me write in blank, okay, so then you will get minus I h cut by twice m and within bracket twice minus infinity to plus infinity psi star del psi by del x dx. That's what you have got, okay, after those simplification. And so that's what we have got. Now here you see these two cancel, so let us use this value here in this above relation. Here we are going to use this value. You can see this. If you use this, then you will get the expectation value of p, momentum. So that's gonna be, that is m. So what you're gonna use here, instead of derivative of time with respect to time of expectation value of x, instead of this term we are going to use this value now. Okay, so let us use here. So using this you will get minus I h cut by m only now, 2 gone, minus infinity to plus infinity psi star del psi by del x dx. Okay, so here m gone. So now what we have got here, you can see, you can consider that you have multiplied I with both the numerator and denominator. Then you can write here, this is h cut by I, this minus sign will be plus now, minus infinity to plus infinity psi star del psi by del x dx, and it can be rearranged as minus to plus infinity psi star, as this part is constant, so you can write here h cut by I del by del x psi dx. So here you see, so this part, as we have got here, this part is nothing but momentum operator. this is called momentum operator, and this operator operates on psi. Okay, so hope you have understood. Similarly, we can find a kinetic energy operator. Here you see kinetic energy T is given by half mv square, isn't it? Half mv square. So if you take the expectation values here, you see this term can be expressed as 1 by twice m. So you can write mv whole square. Now you can write mv whole square. So m into v is nothing but momentum, so we can write p square by twice m. Okay, so if you take the expectation values, here, just what to do, if you find the expectation values of t, you have to replace this p here in this relation, replace all the p's by this operator. Then what you will get, a momentum operator, as there is momentum square. So what you will get here, so this is constant term here, minus infinity to plus infinity psi star. So you will get 1 by twice m, and h cut by I del by del x, so square psi dx. Okay, you get this, and after simplification, what you are gonna have, minus h cut square by twice m, minus infinity to plus infinity psi star del 2 by del x2 psi dx. So you will get this. So here you see, so here this term, you can see this term, or you can say minus h cut square by twice m del 2 psi by del x2, del 2 by del x2, and this is nothing but kinetic energy operator. So hope you have understood this. So if you have understood, please share this video with your friends, and if you are new to my channel, please subscribe the channel. Thank you for watching.